I just wish you had come earlier, Professor.
Oh, Farid. What happened?
I was about to switch on the light, but I tripped and fell.
Talking about light, do you know that light is the most important form of energy?
Yes, light is the most important form of energy, but my leg is still painful.
Well then, perhaps you better go and rest. Let us now look at a few sources of light. The sun is the most important source of light. This is a torchlight. When I switch on the torchlight, it produces light. Let me show it to you again. Other than that, we have candles, electric bulbs, and bonfires. When I switch on the torchlight, what do you see? A ray of light is produced from the torchlight. Is it true that light travels in a straight line? Yes, you are absolutely correct. Now, using this torchlight again, I will point it at a mirror. A ray of light is coming out from the mirror. Well, this phenomenon is called the reflection of light. So, through this activity, we now know that light can be reflected. And there is another property of light that we should know. We see it every day, but we do not realize that it is one of the properties of light. Let me show you. I have an empty beaker with a pencil in it. Look closely. Is the pencil straight or is it bent? Let me pour some water into the beaker. Watch carefully. Okay. Voila! Look at the pencil. Hey, the pencil in the beaker of water looks bent. Is it really bent? Let's take the pencil out. No, it's not. It is still straight. So, what happened? This is because light is refracted when it travels through two different mediums with different densities. So far, we have learned about the properties of light. There are three properties of light, and they are: light travels in a straight line. Light can be reflected, and light can be refracted. Hi, Farid.
Hi, Professor Gloop.
What are you doing with the torchlight?
Well, Prof, I want to find out why the light from this torchlight can pass through this piece of glass but does not pass through this cardboard.
Well, that's pretty simple. You see, a glass is a transparent object. On the other hand, the cardboard is an opaque object.
Wait, Professor, what is the meaning of opaque?
Well, opaque means not transparent. Objects which are not clear do not allow light to pass through. Instead, the light is reflected. So light can travel through a transparent object, but not through an opaque object. Let us see another example. Replace the glass with a piece of clear plastic and replace the cardboard with a piece of plank. Can these objects let light pass through? Very good, Farid. You have understood the difference between a transparent and opaque object.
Thank you, Professor.
Well, I have a question for you. Find out what is the meaning of a translucent object. Bye. Gotta go now. Bye-bye. Many people wear spectacles. Why do they wear spectacles? Well, these people wear spectacles because we have defects in vision. There are various defects in vision. We shall discuss two major defects in vision that are most commonly experienced by mankind. They are long-sightedness and short-sightedness. When a person has long-sightedness, her vision of near objects is blurred. She can't see objects close to her clearly. When a person has short-sightedness, far objects appear to be blurred. He can't see objects that are far away. Why is this so? There are certain reasons why people experience long-sightedness and short-sightedness. We can explain these reasons when we identify where the object image is positioned in the eye. The position of the object image for a person without any visual defects is as shown in this diagram. The object image falls on the retina of the eye. However, when a person has long-sightedness, the position of the object image is moved from the normal position to the back of the retina. This defect is due to the eye lens being too thin. The defects of vision can be corrected by wearing spectacles. There are two types of lenses that are commonly used, namely the convex lens and the concave lens. The convex lens is thicker in the center and thinner at the sides. Whereas the concave lens is thicker by the sides and thinner in the center. This is how we can differentiate between these two lenses. Let's see, which lens is used to correct long-sightedness? This is what happens when I use a concave lens for long-sightedness. But when I use a convex lens, the object image is positioned back to the retina. To correct long-sightedness, wear spectacles with convex lenses. The object image is positioned back to the retina when the convex lens is used. How about short-sightedness? When a person is short-sighted, the position of the object image is moved from the normal position to the front of the retina. This defect is due to eye lens being too thick. Let's see which lens is used to correct short-sightedness. This is what happens when I use a convex lens for short-sightedness. But when I use a concave lens, the object image is positioned back to the retina. Like this. To correct this defect, wear spectacles with concave lenses. The object image is positioned back to the retina when the concave lens is used. It is pretty easy to touch the nib of the pen with both my eyes open. But when I try it with one eye closed, I can't touch the rib of the pen easily. Why is this so? Vision using both eyes is called stereoscopic, and vision using only one eye is called monocular vision. Stereoscopic vision is present in animals with the location of both eyes in front of the head. The field of vision is narrow and it overlaps at certain points. Estimation of distance is accurate. On the other hand, the eyes of the animals with monocular vision are located on both sides of the head. The field of vision for these animals is wider and does not overlap at any point. The estimation of distance by these animals is inaccurate. What are the differences in stereoscopic vision and monocular vision? In stereoscopic vision, both eyes are used when looking at an object. But in monocular vision, only one eye is used. The location of eyes for stereoscopic vision is in the front of the head, whereas for monocular vision, it is by the sides of the head. The field of vision for stereoscopic vision is narrower compared to monocular vision. The field of vision for the stereoscopic vision overlaps but not for monocular vision. So, stereoscopic vision has a better estimation of distance compared to monocular vision. Can you identify the type of vision for each of these animals? A tiger has stereoscopic vision. A cat also has stereoscopic vision. A fish has monocular vision. A cow has stereoscopic vision. A bird has monocular vision. A goat has stereoscopic vision. An elephant has monocular vision. A mouse also has monocular vision. Now, we know that animals have two different types of vision. How are these types of vision important to them? A cat has a stereoscopic vision. A bird has a monocular vision. The cat is a good hunter because it has a good estimation of distance. But how could the bird escape? Well, the bird could escape because the bird has a wider field of vision. So it managed to escape swiftly. First, we learned about the sources of light. That is, the sun, the torchlight, burning candles, electric bulbs, and bonfires. We have also learned that light can travel through objects which are transparent, but it cannot travel through objects that are opaque. Do you still remember why some of us need to wear spectacles? Yes, this is because we have visual defects. There are two types of visual defects that we have learned today, namely long-sightedness and short-sightedness. And these visual defects can be corrected by using the appropriate lens. We have learned about the convex lens and the concave lens, which have different characteristics. Lastly, we have also studied about stereoscopic and monocular vision and its differences. Based on this table, we can differentiate between the stereoscopic and monocular vision. Well, what about you out there? Can you remember what we have studied today? Is your vision normal? Are you short-sighted? Or are you long-sighted? If you are, have you corrected your vision? Discuss this with your friends in class later. Okay, so bye for now. Take care.
Have you ever stopped and wondered why we are able to see the things we see? It's because we have a little light, a pair for you and a pair for me. Sun, the moon, the stars shine in the sky, giving us the light we desperately need. That's so important to the eye. Darkness is an enemy indeed. Did you know that light travels in a straight line? Transparent and translucent things all the time, that it gets reflected and reflected along the way. It happens in the night, it happens in the day. If life is something that's all gray, a great big shadow it will make. But what you see can get distorted, because your eyes can play tricks on you.